So moving on, I think it's important to talk about infinity, and because we talked about it, but maybe we don't understand what it is. So basically, infinity, a way to understand it is just think of the biggest number you can think of. Any number. Now, put a 0 at the end. So let's try that out. I'm going to put huge number. The biggest number I can think of. Not really, but okay. Then we can always add a 0. But then we can add a 0 again, and again, and again. And this process could go on forever. So basically, when we talk about domain and we say, oh, the function is happening all the way until infinity, it literally means that it will never stop. It exists all the way on the horizontal axis, all the way, but it's never going to stop. It's always going to keep on going, and that's why we use the parentheses and not the bracket for infinity. And basically, anything you take away, you will still have as much left. You will have equally as much left because it always keeps on going. Infinity is a value that always keeps on going, and can't even call it a value for that matter. It's just something that keeps on going. That's why I use the parentheses. So basically, what we're gonna move on to do in the future, and we're gonna give you a little sneak peek here about stepping it up a notch, if you will, is that we're gonna talk about when we use interval notation, but we basically make it more complex, in a sense, where we're gonna need to use for a domain. This will almost always be for the domain, but when we're going to need to use for the domain, where only one set of parentheses is not going to be enough. Just saying this, comma, this is not going to be enough. We're going to need something more to make our domain accurate and portray what we're seeing in the graph. We're going to need something called a union, which is basically a device that allows us to give more than one parentheses set for a domain. And we're going to need to put one more or two more or three more or how many more you need. But in this, we would use it in a case, for example, like this, where there's a little line called an asymptote separating right here. But if we want to put a domain, we know that the function is happening all the way there, but it stops right here. So right here is going to be negative infinity to that number right there, which is negative 3. Parentheses. And then we see that it starts again from negative 3 all the way. So we're going to put a union. Sorry about that. We're going to put negative infinity to negative 3. Because right here at negative 3 it stops. At this imaginary line it stops. But then it starts again right here. So boom, union. Slap that right there. And negative 3 right here. And then all the way to infinity, comma, or to infinity. And close the parentheses right there. So basically that was the essence of the x-intercept, y-intercept, domain, and range, and interval notation. And this was kind of long, but it's important to get us introduced to what we're going to do later with different types of functions where domain and range are going to become more important to figure out graphically and numerically. That's it. Thank you.